This video is about congruency. What does this word mean? Congruent figures are exactly the same size and shape. This means they have the same angles and the same lengths. Although we're looking at congruent triangles, congruent figures can be any shape, as you can see down here. When proving congruency in triangles, it would be a lot of effort to prove that every corresponding side and every angle are equal to each other. So instead, we have developed tests to prove congruency with the minimum steps required. So down here, this is the symbol for congruency, or if you are handwriting, it's just this symbol here. So we use a little triangle to indicate that we're referring to the whole triangle, and then we put this in the middle to say that it is congruent to this other triangle. What are the tests for congruency? We have four main tests that we use to prove congruency in triangles. The first one is SSS for short, and that refers to side, side, side. And this means that all corresponding sides are equal in length. The next one is SAS, or side angle side, and this means that two corresponding sides are equal in length and the included angles are equal in side. So you can see here we've got the equal sides and the included angle between those two sides are all equal. ASA, or AAS, is angle side angle, or whichever order you want to put it in. And that means that two angles are equal in size and there is one pair of corresponding sides of equal length. And the last one is RHS, or right angle hypotenuse side. In a right angle triangle, the hypotenuse and one pair of corresponding sides are equal in length. So let's have a go down here at identifying which test to use. So here I can see that indicated by the two dashes here and the two dashes here, that side BA is equal to side ED, so I can use S for side. This angle here, angle BAC, is equal to EDF because they've given us these angles. Both of them are 80 degrees, so I can use angle. And then AC, indicated by this one dash, is equal to DF, which also has one dash, so this side is equal. So for this first one, A, we can use side angle side to prove congruency. Over here, we can see that angle ABC is equal to DEF because both of these angles are the same as indicated by this little circle. So that is an angle. We also have this angle DFE, which is equal to BCA, indicated by the little X. So we have another angle. And finally, we have one dash here and one dash here. And that means that DE is equal to AB. And so we have side. So angle, angle, side, or angle, side, angle means the same thing, is what we can use to prove congruency here. All right, let's have a go at a full example of a proof. So proving triangles are congruent, it's not enough to just say that they're congruent using one of these four descriptions. You need to show how you know each statement. It could be given, like the ones down here, so they've given us enough information, or you may need to give another reason. So, prove triangles ABC and EDC are congruent. So I'm going to start off with a statement in triangles ABC and EDC. Now, I'm going to write three statements down here and I'm going to number them to keep this really clear. Number one, this side, AC, is equal to this side, CE, and that's given because it says 8 meters both cases. So AC is equal to CE, and then in brackets, I'm going to say given. Okay, so that's S for side that we've got so far. What else can we say? Well, we know that vertically opposite angles, so this angle here and this angle here, are going to be equal. So I'm going to say angle ACB is equal to angle DCE. And the reason is because they are vertically opposite angles. Okay, so now we have S and we have A. Third statement, what else can we say? Well, we've been given some parallel lines here indicated by these arrows, and we have a bit of understanding about equal angles within parallel lines. And so I'm going to look at angle A, B, C, and angle EDC, so this angle here and this angle here, and they're going to be equal because they are alternate angles in these parallel lines. So angle ABC is equal to angle EDC, and that is because they are alternate angles in parallel lines. So I'm going to say that I'm going to state the parallel lines. I'm going to say A, B, two vertical lines to say parallel, D, E. So alternate angles in the parallel lines A, B, and D, E. And so that is another angle. So now we have to finish these proofs with a concluding statement. So the concluding statement, therefore, triangle A, B, C is congruent, so the three-lined equal sign, to E, D, C, because of angle, side. So I want you to try and structure your proof like this. So you need at least 3 statements. You need in brackets a reason for each statement, whether it's as simple as it was given or whether it's something else. And then a concluding statement at the end indicating which of the 4 congruency proofs did you use. Let's have a go at another example. Okay, so this has 2 parts. First, prove the triangles are congruent, and then prove that 2 sides are equal. So we'll start off with A. So in triangles, DAB and DCB, we need our 3 statements. So number 1 is going to be that angle DAB is equal to DCB, and that is given because we can see that they are both right angles. So angle DAB is equal to angle DCB, which equals 90 degrees, and that is given. Okay. Number 2, this side here, side DB, is a common side. It's the hypotenuse for this triangle and the hypotenuse for this triangle. So I'm just going to say DB is common. Okay. And then 3, AB is equal to BC, and that's given. So AB is equal to BC, and that is given. So we have, we've got the right angle here, we have the hypotenuse here, and we have one other side. So our concluding statement, therefore, triangles DAB congruent to triangle DCB because of our HS, so right angle hypotenuse side. So part B is asking us to prove that AD equals CD. So AD equals CD. These are now corresponding sides in congruent triangles. So we've just proven that these two triangles are congruent, therefore these sides must be equal. So we need to make a statement there. So I'm going to say triangle DAB is congruent to triangle DCB. So AD has to be equal to CD. Just need to expand on this and give a bit of a reason. So in brackets, they are corresponding sides in congruent triangles. And that is all.